This question is about isomers with the molecular formula C5H10O. Draw the skeletal formula of a branched chain aldehyde with the molecular formula C5H10O that is optically active. Okay, I need to work this out before I draw the skeletal formula. So it's got to be, so let me start with 5 in a row. 2, 3, 4, 5. Let me put my aldehyde on there. So that is that. It's got to be branched, so let me just take one carbon off the end, and I've got to put that carbon on somewhere to make it optically active. So the best place to put it is probably here. So if I put a CH3 there and a hydrogen here, CH2, CH3, just checking the three, but I've got 4 different groups here. So 1, 2, 3, 4. So that would be it. Let me now try and convert that to skeletal. So 1, 2, 3, 4. So 1, 2, 3, 4. I'm going to put the numbers on as well just to make it a little bit easier. So 1, 2, 3, and then 4. So on carbon number 1, I have a carbonyl group. So don't put the hydrogen on. So don't put the hydrogen on there. Remember that skeletal doesn't show the hydrogens. And then on carbon number 2, I have a methyl. And again, that's my working out. So I just need to leave that there like that. Cross it out, make sure it's not marked. Describe how I could distinguish between separate samples of the 2 enantiomers of the branched chain aldehyde. So I would use plain polarized light. So one isomer would rotate in one direction, the other would rotate equally in the opposite direction. Okay. Part C. Draw the E and Z forms of a structural isomer that shows both optical and geometric. So E and Z, that's going to be an alkene. I need 5 carbons and it's got to be optically active as well. Okay, so let's start with the geometric part of it. So this is just going to be my working out here. Okay. So let's put a methyl there and a hydrogen there. So this is going to give me my 2 different groups. And obviously, let me just highlight. So this is going to be my priority group on this side. So if I put so E, so Z is Z-same-side, so E is going to be on opposite sides. So if I put my hydrogen here, and then everything else has got to go here. So what have I used? I've used 3 carbons so far, which means I've got 2 left, and I have to have an optical isomer. So if I've got 2 here, what that means then is that this one is going to have to be my optical isomer because the other one is at the end of the chain. So if I make that a CH3, now I've got an oxygen in here, so let me start with an alcohol. So hydrogen and an OH, and let me just check that all that adds up. So 1, 2, 3, 4, 5 carbons, that's fine. 3, 4, 5, 6, 7, 8, 9, 10 hydrogens, that's fine as well. And 1 oxygen with the alcohol. So yeah, all that is fine, and that is the E isomer. So I just need to redraw that now with the one of the priority groups the other way around. So H3C, again, just thinking about connectivity there. Hydrogen, and then here, C, H, OH, CH3. There we go. So a bit of working out needed there.